Good evening, everyone, and welcome to yet another live with THiNC Institute of Design. We hope you are all preparing with us together for the third NATA that is scheduled for the 7th of August. That's the third, and hopefully that will be the third and the final NATA that's been scheduled. So we have had some previous sessions, question paper discussions, and all for NATA 1 and NATA 2. For this one also, we have been doing this. We have had a couple of sessions. I think earlier we had discussed about couple of sessions wherein we have discussed the second data questions. So in this, we have with us Venkateshwaran sir, who has joined live, and he would be taking through the arithmetic aptitude questions. So if you have any questions that's already there, you can keep it ready. You can have a piece of paper and pen also along with you if you want to work out on certain problems that are going to be discussed. So that's the first thing. Welcome, Venkateshwaran sir. And
Good
regarding the
evening.
next Thank you, sir. And regarding the next announcement that we wanted to make, I think this is something that's familiar for everyone. The 59th curiosity quiz for NATA will be conducted tonight. Hopefully, that would be the last quiz before the third NATA, unless and until there is any change or anything of that sort that's coming up from the NATA or Council of Architecture. So the 59th curiosity quizzes would be tonight at 9 p.m. You can join at the same place with us. We would be here with the questions. And that would be it from the introduction section. I'll hand it over to Venkateshwaran sir. Sir, the stage is all yours.
So thank you, sir. Thank you. And yes, students, good evening, all of you. A great evening for you. So we have got the idea about what we are going to have for today's live session. We are going to again discuss the arithmetic part questions of this NATA exam. So that's going to be the objective of this session. So if you remember already, we had the previous session where we were able to discuss a part of those NATA questions, and we are going to have a continuation part of those questions for today's session. Okay, fine. Yes. Yeah, yes. So I think we can start, but before that, let me just share my screen to you. Yeah, yes, students. So I believe like the screen is visible now. So kindly make sure whether you are able to see the screen, right, students? Yeah, yeah, yeah. And students, if any, you can let us know through the chat box. Okay, yes. So you can give your comments, you can give your response through the chat box. It's open to you. So you can give that. And yeah, I think we can start with the questions directly. So yes, students, if you remember the previous session, we had a set of questions discussed there. So we saw questions based on numbers, questions based on percentage, ratio, average, and all these things. And also we discussed in the last part of our session, we happened to discuss questions based on geometry mensuration also. Okay, we had some good questions, standard questions asked this year in the NATA exam. And as its continuation, I would like to give you other few questions also. We'll continue from there, where we left there. So we'll continue it from there. So I would like to give you questions from there. So yeah, let's continue. So let me start with the question. So again, let me give you questions based on a question based on geometry and mensuration. Okay, all right. Yes. So yeah, here is your question. So here's the question for you. Okay, yes. Yes, students. Yeah, I'll put the question on the screen and kindly give your response, students. So I believe you will be able to see the question now. So there are around some 10 people watching this session live. So here your first question on the screen, students. Come on, please give a try and then get the answer. Yes, students. So I'll give a few seconds time for you. Just give a try. So any answers for this first question? Come on, any answers, please? So this first question is purely based on, this is based on something based on mensuration. So can you give a try, students? So what's the answer for this first question? Can you please give a try? Yeah, come on. I started getting the answers. Kiran, Sarat Chandra, Sai Danvat, Mohammad Ladeed. Great, great. Good to see the responses. I'm able to get the responses, but at the same time, I'm getting different responses from you. But doesn't matter. Okay, anyways, you keep trying. Okay, okay, all right. So I think we'll put into the general discussion. Okay, fine. Yes. Yeah, coming back to this question, students, this question is it's giving the data like if the perimeter of the circle and that of a square are both equal. So that means there is a circle there and you have a square. So given both the perimeters are equal. So we all know the perimeters, right? So perimeter of a circle, we call it a circumference. Circumference. All right. Yeah. Okay. And what about the perimeter of a square? Perimeter of a square means we add all the four sides of the square. So given these two quantities are equal, then what is our question? The question says, then what is the ratio of their areas? The ratio of their areas will be equal to what? So which among the four options? So we need to find the ratio of the areas. That is going to be the task. Okay. All right. Yes. So given the circumference of the circle and the perimeter are equal. So we know the circumference in terms of radius. Okay. So it will be 2 pi r for the circle. And what about the perimeter? Perimeter we know in terms of the side. Okay. Each side of the square is going to be a, right? So it will be a plus a plus a plus a, which means it's 4a. So given these two are equal, so that means I can very well equate 2 pi r is same as 4a. Yes or no, students? I can do this. So now what we can do here is, the next thing what we can do here is, we'll try to get a relation between this radius of the circle and the side of the square. So once I try to do that, I'll be getting, I can cancel this. I'll be able to get this A equals to, this A is equal to pi r by 2. Fine, okay. So you can either try to express radius in terms of the side or otherwise side in terms of radius. Whichever is better, you can go for that. Okay, fine. All right, students. Okay, all right, yes. Now next, what is the next thing we can do here? We need to find the areas. Okay, we need to find the area of the circle and area of the square. Okay, so we know the area of a circle and area of a square. So they are going to be nothing but, oh, yes, they are going to be, yeah, yes. So I am coming down. Yes. Yeah, okay, now better. So area of the circle is going to be nothing but pi r square, and area of the square will be a square, right? Okay, so we need to find the ratio of these two quantities, which means pi r square. Let's put this pi r square as it is, and we have the value of a in terms of r, correct? So let's use this definition over here. We'll use this here. So if I try doing that, I'll be able to get a square, which means pi r by 2 the whole square. So we need to simplify this. So this will give you pi r square is to pi square r square by 4. Is it or not? Yes or no? Because you expand this expression, you'll be able to get this. And still we can simplify this, right? We can even simplify this further. We'll be able to simplify this further. We can simplify this as, I can cut this pi and pi, one of the pi. I can cut this r square and r square. So finally, I'll be left with what? I'll be left with 1 is to pi by 4. Yes, yes, yes. So this is what we'll be having. And we need to express our answer in terms of numbers. So that is what we have in the question. So to do that, we can get it as 1 is to pi by 4, right? So pi by 4 can be written as 22 by 7 by 4. So I think now we have turned into numbers, right? Okay. Actually telling pi in default way, we'll write as 22 by 7. That's what. Okay. Yes. So this can be simplified as, I can cut this like 1 is to 22 by 14. And further, I can simplify this as I need to come down a bit. Yeah. Yes. So further, this can be simplified as 14 is to 22, which means 7 is to 11. Okay. Yes. So this will give you the final answer, right? Yeah. Yes. So the ratio of the areas. Okay. Yeah. Yes. So we need to find the ratio of the areas will be equal to in what ratio. So that is what is asked in the question, right? Yes. So area of the uh, circle and area of the square. This is what we are asked to compare. So this is what we'll be getting, right? 7 and 11. Oh, I'm really sorry. Just a moment. Yes. So this is 28, right? Actually, I'm really sorry for that. 28, 28, 28. See here, this is 22 by 4 sevens are 28 actually. So 28 is to 22 will give you 14 is to 11. So I think that has to be the right answer. 14 is to 11. Success. Option D. Option C is the right answer. See here actually telling option C is 14 is to 11. Option D is 11 is to 14. Okay. There's a small swapping between those two options. We have to give the answer in the way how it is given in the question. Okay, fine. Yes, the same order which is given in the question is to be projected. How it is asked in the question, the same way we have to get it in the answer. Okay, fine. Yes. So this is one approach with which we can get the answer. Okay. So are you okay with basically the steps here? So what we do clearly is we just take the ratio of their areas. We are just going to get in terms of the same variable. That's what I have tried here. So you can do like this, pi r square. Here a I'm turning in terms of r, and there onwards we try to simplify this in terms of numbers. So after we turn into numbers, we are going to simplify this. Okay, fine. Yes. So if you want, I can rewrite it in a clear way. Okay, why? Because I have just made it. I have scribbled here. That's the reason. So this will become 1 is to 22 by 7 fours are 28. Okay, so this is the clear step. And now I can turn it as 28 is to 22. Okay, fine. Yes. Because this can be multiplied, right? Whenever we have a ratio, we can multiply like this, cross multiply. So 28 is to 22. This on simplification will give you 14 is to 11. So that will be the answer for your first question. First question. Yes. So is that okay, students? Very able to feel a bit comfortable with this problem? So it's a very basic problem only. Fine, yes. Yeah, okay. Yes, students. Okay. Let me give you another question for you. Okay. Yeah, yes. We'll go to the next question. Okay, here is the next question for you. I am checking like we don't repeat the problems. Okay, fine, yes. Because we have seen a certain question, certain set of problems already in the first session. So we see that we are not repeating the question. So I believe this is again a fresh question for you to try, which is based on numbers. So students, I want you to try the next question. Okay, yes. So shall we move on to the next question, please? If you permit, I will move on to the next question. Next question. Yeah, yes. So yeah, I will give you the next question over here. Yeah, come on, students. Again, a very easy kind of question given for you. Can you please try this question, students? Yes, come on, please. Yeah, any answers for this question? It is again an easy question based on numbers. Any attempts for this answer? Okay, great. I got one answer. How much Sheikh is giving an answer? Good, good, good. So there are some 16 people watching this session. Come on, you can give your try. Sarat Chandra, great. Good to see that. Okay, all right. So I think we can do this question together, right? Time is up. Okay. So this is again a very easy question only. Given the sum of two numbers is 5 times their difference. There are two numbers. Sum of them is equal to 5 times the difference. And if the smaller number is 24, find the larger number. That's it. Okay. So we'll take those two numbers to be x and y. And I will take the larger number as x, smaller number as y. So that means our task is here to find out the value of y only. Okay. Yes. Oh, I'm really sorry. The task here is to find the larger number. Find the larger number means x is what we have to find. We have the value of smaller number given to be 24 in the question itself. So y is 24. That's it. Okay. Now, all right. Come to the first part of the question. Given the sum of the two numbers equals to 5 times the difference. So this is the relation they gave here, which means what? X plus y is equal to 5 times of x minus y. And that too, we got to know the value of y. So y is 24, just substituted. X plus 24 equals to 5 into x minus 24. Now all we need to do is just solve this linear equation and get the value of x. So I think now you'll be able to get the answer easily. Yes, students, can you just try from here? Just a quick step we are going to do. Just get the value of x. That will give you the answer for the question. Good, Chitragupta, Sudiksha. Yes. Okay. See, students, the idea we took x plus y and x minus y, it is following from a very small logic. Okay. Sum means we all know x plus y, but difference means it will mean the larger value minus smaller value. That is what particularly we are taking x minus y. Okay. So be clear with which one is the larger, which one is the smaller. There we should be very, very careful. Okay. Yes. Yeah, fine. So we'll continue the steps now. X plus 24 will be equal to, now right hand side, just multiply this 5 inside. You will get 5x minus 5 into 24 will be 120. And now what next we can do? We'll bring x terms to one side, numbers to the other side. So we will be getting 4x equals to 144, right? That's what we will be getting, right? Because this x you can bring here, it becomes 5x minus x, 4x. This minus 120 you bring here, this becomes 120 plus 24, 144. So 4x is 144 means x is equal to 144 divided by 4, which will be 36. And that's your answer, finished. So I'm able to see few of you gave the correct answers. Very good. Good to see that. Got it, students? Please check the steps and let me know if there are any doubts. Clear with this, right? Clear with this? Okay, yes, students. Okay, now next, another very good question based on exponents. I will give you a question based on exponents. Get ready for the next question. A very good question, but the thing is, you must be really careful in working out the answer for that question. Okay. Yes. Yeah. Okay. So, but meanwhile, please check whether you are able to understand this problem. Clear with the steps, right? Yes. Okay. Fine, then I will come to the next question for you. Yes, students, here is a question which I told about. This is something based on exponents and roots. So I would request you to work this question carefully, okay? Because it contains trap answers. So be clear with the trap answers before you attempt give the answer. Come on, try this question. Yes, any answers? Now I can see answers. Okay, okay. Slowly I'm able to see the answers. Great, great, great. Very good, very good. Good. I can see the responses one by one. Good. So that's why I told this year's NATA we have got so standard questions. Okay. So the questions are standard enough that when you compare it with the previous year's questions, it's getting so standard. Okay. So the way you need to prepare yourself should also get better in that way. Okay. It should match that standard of the question papers, the questions, how they ask. That's what is really important. Okay. Yes, I appreciate the those who are giving the answers. Good to see that. Yeah, anyways, we'll quickly get into the working approach. So here the next question is the product of the square root of x with the cube root of x is equal to what? That's our question asked here. And here we have the options. Now, what do you mean by square root of x, cube root of x? Square root of x, we all know. This is how we write square root of x. And cube root of x means this is how we write. We'll put a 3 here and we'll put a root x. Okay, this we will read it as cube root of x. Okay, and of course square root of x is nothing but you put a 2 and you put a root x. Okay, but by default it is understood that when we write root itself, it is understood that it is square root. Okay, fine. Yes, but in detail this is what is square root of x. Okay, fine. Yeah, okay. So what we need to do here, we need to find the product of these two values. Okay, product means we have to get the multiplication. So this is basically nothing but the square root of x can be written as, this can be written as what, students? Any idea? Can anyone tell me that? When you have an nth root of an expression, that can be rewritten as what? That can be rewritten as what? Any idea, please? Yeah, x to the power half. Brilliant. Very good. Very good. Yeah, you can rewrite it as x to the power 1 by 2. Same way, cube root of x can be rewritten as x to the power 1 by 3. Okay, fine. Yes. So this follows from the basic axiom. Nth root of x will be nothing but a to the power 1 by n. So with this axiom is what we are doing this. Okay, yeah, fine. Now next is when you have the common bases, when they get multiplied, what we do with the power, students? What you have to do? That is when you have a x power m multiplied with x power n, what we do here? We have to do x to the power m plus n. We should add the powers, right? When you have a multiplication, we should add the powers. So we do the same here, x to the power 1 by 2 plus 1 by 3. So what is 1 by 2 plus 1 by 3, students? That gives you what? 1 by 2 plus 1 by 3 will give you how much? Can you carefully add it? Yeah, that gives you, good, very good. I'm able to see frequent responses from Pranesh. Good, good. Yeah, Samad. Yeah, good. So this will give you x to the power 5 by 6. So x to the power 5 by 6. Now, closely watch what I'm going to do here. I'm just going to make a small adjustment here. Okay, I will rewrite this x to the power 5 by 6 as x to the power 5 whole power 1 by 6. I can do this, right? I can very well do this, right? Because we all know the axiom x power m whole power n. This is nothing but x power mn. I'm just coming from here to here. That's it. Okay. Yes. So that when you multiply the powers, you will get back to the same 5 by 6. That's why. Okay. Yes. Now, once again, I will use this nth axiom. Okay. This power 1 by 6, I will rewrite it as 6 root of x power 5. Got it? Understand? So my final answer became 6 root of x power 5. Now look at the options and confirm your answer, students. So which answer option will become your correct answer? 6th root of x power 5. So now which option perfectly suits? Option B is your right answer. Yes, option B is your right answer. Now look at here, 6th root of x power 5, which is 5th power of x. That's it. That is your answer. So option B is the right answer for this question, students. Okay, fine. Yes. But as I told, if the students are not much aware of the axioms, there are more chances to get wrong answer for this question. You have got more chances of getting wrong answers. Now listen, what students will do is they will come till this step, x power 1 by 2 into x power 1 by 3, and suddenly what they will try to do is when they multiply, by mistake they will multiply the powers 1 by 2 into 1 by 3, and they will end up with x to the power 1 by 6, and they may mark option D to be the answer. This happens. Okay, but be clear, options are well set with trap answers. You should be very clear that you are not falling into those traps. Option D is a purposely fixed trap answer there. Okay, so this way of working out the problem is not correct. Okay, when you have same basis getting multiplied, the powers will get added. That you have to keep in your mind. Got it, students? Got it? Understand? Yeah, fine. Yes. So now I think we can go to the next question. If you are ready, we can go to the next question. Next question. Okay. Students, here we have a question from time, speed, and distance. Time, speed, distance. And of course, this is, again, I will tell, this is something very closely repeated question from the previous NATA exam that was conducted recently before question. So I would I would just want you to try this question. So let me give you the next question. So with your permission, I will come down, scroll down the page. So please, students, if there are any doubts anywhere in between, you can let me know. Okay. So are you clear so far, students? Is it looking so far clear for you? Okay. Okay with the questions? Okay. Yes. Okay, students. Okay, fine. Thank you. Yes. Now going to the next question. I want you to try this next question. Come on, please go give your attempt. Yes, come on. Answers. Yeah. Nice, nice, nice. Good to see the responses. Mm-hmm. Yes. Good. Kiran, Nazmia, Samad. Okay. Yes, yes, yes. Yeah, I think we'll come into the general discussion. So come on. Yes. This question we have, excluding stoppages, the speed of a bus is 54 kilometer per hour. And including stoppages, the speed of the bus is 45 kilometer per hour. So this is about a bus traveling, and they're giving excluding stoppages. What do you mean by excluding stoppages, students? That means without stoppages. Okay. So if the bus is traveling without stopping anywhere, if it is going to travel with its constant speed without stopping anywhere, the bus is able to cover 54 kilometer in 1 hour. Got it? Understand? Fine. Yes. So 1 hour is basically 60 minutes. Is it or not? So in 60 minutes, the bus is able to cover 54 kilometer. But including stoppages, that means if the bus is going to travel in the stoppages, okay, bus is going to stop there in the stoppages. Okay, if it is going to stop in the first stop, it will spend some time in the stoppage, correct? Then it will leave the stop. It will again continue the travel. Likewise, if the bus is going to spend its time in stoppages, okay, now with stoppages, the bus is able to cover 45 kilometer in same 1 hour, 45 kilometer in 1 hour. So this is what they try to tell here. Okay, fine, yes. So be clear with the question. Without stoppages, it can travel 54 kilometer in 1 hour, but with stoppages, it can travel only 45 kilometer in 1 hour. Remember, the bus, while it is traveling, its speed is not changing. While traveling, the speed is the same. But here, the thing is, the difference is only because it stops and it is not stopping. That's it. Okay. Now, finally, what's the question? Then, for how many minutes the bus is stopping in the stoppages? Every 1 hour. So, per hour, how much time it is spending in the stoppages? This is all our question. Okay, let's do it very technically. See, if the bus is able to cover 54 kilometer in 1 hour, let's do the technical calculation. The same bus will be able to cover 45 kilometer in how many minutes? Shall we calculate this? Shall we calculate this? So maybe once you calculate this, this will be giving you the answer in a very clear way. I repeat my question. If the bus can travel 54 kilometer in 60 minutes, with the same speed, it can travel 45 kilometer in how many minutes? So this is what I'm asking as my question. Let me take this as some x minutes. So since this is a direct proportion, you can just do it like this. Okay, you can multiply x into 54 and you can equate it to 45 into 60. Okay, you can do it like this. X into 54 equal to 45 into 60. So maybe you can try getting the value of x here. Okay, so can you try getting the value of x here, students? Now can you get the answer, please? That's a direct variation, right? Because when speed, or I mean like when distance decreases, time taken will also decrease because the bus travels with the same constant speed. In that sense, if the distance decreases, time will also decrease. So that's the reason I'm doing it as a cross multiplication. So now can you try getting the value of x, students? X will be what? X is what? Or I can even give you another smarter method. Okay, I'll give you another smart method. Listen here carefully. What other way? Otherwise, what you can do is just forget all these things. Okay. Otherwise, what you can do is just listen carefully, students. Let me try taking the answer, getting the answer through ratios. Now see the distance here and time here. Now see distance and time, they both are proportional here, right? So just see the distance as value 54 and 45. Can you please tell the ratio, students? What is 54 is to 45? Come on, quick ratio. What's the ratio? Come on, please tell me the ratio. 54 is to 45. What's the ratio of the distances in the two situations? Hello? Distance, what's the ratio, students? Any answer, please? I mean, all I ask is, what is the ratio 54 is to 45? What's the ratio? Yeah, the ratio is, you can cut with 9 tables, right? Yeah, you can cut with 9 tables. Both are divisible in 9 tables, right? So you can cut with 9 tables. This is 9 6 are 54. This is 9 5 are 45. So ratio is 6 is to 5. So once distance ratio is 6 is to 5, time ratio will also be the same because of the proportional relation. Time should also be in the same ratio, 6 is to 5. Now in the place of 6 is only the 60 is there. Just check how many times it is. 6 tens are is 60. Now do the same here. 5 tens are 50. So x is 50. That's it. So that means the bus is able to cover 45 kilometer in 50 minutes. So x is 50 minutes. That means in that same 1 hour, the bus is traveling only for 50 minutes, which means what's the remaining time, students? The remaining time is what? Out of 60 minutes, 1 hour, the bus is traveling only for 50 minutes, means the remaining time is how much? It's going to be 10 minutes. Is it or not? Because 1 hour is 60 minutes. If the bus spends 50 minutes for traveling, the remaining time is 10 minutes. This 10 minutes, the bus is spending in stoppages, which is your answer. 10 minutes is your answer. Finished. And yes, students, you have got quick shortcut tricks and all to do this problem. I agree with that. But still, I want to give this with the proper basic conceptual explanation. That's the reason I'm taking this steps to make you verify. Okay. You're able to understand that? So I'll quickly give that. If you don't consider the stoppages, the bus can cover 54 kilometer in 60 minutes. But if you consider the stoppages, the bus can cover only 45 kilometer in 1 hour, in 60 minutes, same 60 minutes. But what I calculate is, if the bus is traveling without stopping anywhere, the same 45 kilometer, it can travel in how much time? We calculated that we got it to be 50 minutes. So that means the bus is traveling only for 50 minutes in that 1 hour duration, which means that extra 10 minutes it spends in stoppages. That's it. Finished. Is that giving sense, students? Is that giving sense to you? Okay with that? All right, fine. Yeah, okay, yes. So I think we can move on to the next question. Next question. Yeah, I'll come down. Students, let me put the next question based on ratio proportion for you. Okay. Ratio proportion. So I want you to try this next question based on ratio proportion. Come on, please try this question, students. Okay, I'll slightly come down. I believe all of you are able to see the question. Yes, come on. Please try this ratio proportion question, students. Come on, please. So given this question, you have the total and you have the ratio. But the thing is, the ratio is given, or the ratio is expressed in terms of fractions. That's the only part you should be careful. If you do a kind of small adjustments there, you can easily get the answer. Come on, try and get the answer. Any answers, please? Any answers? Okay, I think we'll do it together. Shall we do it together? I'm really sorry that I'll not be able to give more time. Okay. Okay. No worries, no worries. Because we thought to plan to give you as many questions as possible. That's also a reason. Yes, students? Okay, da. Yes, students. Fine. Yeah, we'll do it together. So given an amount of rupees 782 is divided into 3 parts in the ratio 1 by 2 is to 2 by 3 is to 3 by 4. See, students, the moment when the ratio is given in terms of fractions, what you need to do there is you need to just express this fraction. You have to simplify this fraction as only integers. So without fractions, without decimals, you have to provide the ratio first of all. Okay, we need to simplify the ratio. Then we can proceed and get the answer. So what we can do here, students, whenever a ratio is given in terms of fraction, what can be done there? You need to take the common multiple of the denominators. That is, you can go for the LCM of the denominators. Now look at these numbers, students, 2, 3, 4. What's a common multiple? Tell me a common multiple for 2, 3, 4. 12. 12 is a better number, right? Very good. So 12 is a common multiple. Of course, 12 is the LCM of these three numbers. 2, 3, 4, right? Okay. Do a very simple thing. You can multiply each of these fractions by 12. Now 1 by 2 into 12 will give you what, students? That gives you 6. 2 by 3 into 12 will give you 2 by 3 into 12 will give you 8. And 3 by 4 into 12 will give you 9. So 6 is to 8 is to 9. That's it. So this is going to be the simplified fraction. You understand that? Able to understand that? Yes, students. So you are simplifying the given fraction. You do it like this. Take the LCM and then you multiply that. Okay. So that will give you the simplified fraction. Now I don't think it will be a very big deal for you to get the answer. So 6, 8, 9. So totally how many parts, students? 6 plus 8 plus 9 will be how much parts? So I think it will be 23 parts. Correct? Yeah. So 23 parts is what is 782, which means one part will be how much, students? 782 by 23. Can you divide this? Unfortunately, you cannot cancel the numbers, right? You cannot cancel 782 and 23 because 23 is, of course, a prime number. You'll not be able to simplify the fraction. So the only way is you can divide it. Okay. So better we will divide this. So 23, 789. So I think you can go up to 23, 3s are 69. You can go up to 3 times. So here balance will be 9, 2, and 23 4s are 92. So you will have exactly 4 times. So one part is 34. And what's our question, students? Then what is the first part? What is the first part? First part is how much? 6. It's going to be 6 parts. So one part is 34, which means 6 parts will be 34 into 6. This will give you the answer. So what's the answer, students? So 180 plus 24, 204. 204 rupees is the answer. That's it. Clear? Clear with that? So I got one correct answer from Nazmia. Good, nice. Okay with the steps, students? So I don't think you will have to struggle more for this question. The only thing is we need to simplify this ratio. Once this step is success, then the rest is all easy. Okay, fine, yes. So to simplify, just go for a common multiple. Okay, why do we go for a common multiple, students? Only then we can avoid a fraction. Okay, fine, yes. We avoid a fraction. We can bring all the parts as numbers, integers in our ratio. Then it will make the task very easy. That's why. Okay. Okay. So students, clear with this question? Clear? Are you okay with this question? Okay with that? Fine. Okay. Sure. Yes. So I think let me give you a bit different kind of question for you. Okay. Here is a very good question. So yes, students, here is a very good question from time and work. So from time and work also you see questions in NATA exam. But this kind of question, after a quite long break, you are able to see this kind of questions under time and work. Okay. So I think I will give you the next question, the time and work question for you. Yeah. Here is your question. Just take few seconds and give your answer, students. Come on. Please try the question. Come on, any answers, students? Any answers? Such a good question is this. Sorry. I think we'll work the question together. Ready? Okay. Well, there are many approaches to work out this question, students. There are many approaches. Okay. So these kind of standard time and work questions, you have got more approaches. You can work. You can use the min days ratio. You can use the min days efficiency relation. There are many approaches. One good or practical, very easy way to visualize approach one way is we can try working the questions in terms of units. Units. We'll work the question through units. Okay. So when I try to use units and solve the problem, it will be very easy. Okay, that's why. So now coming to the question, there are 14 persons. 14 persons can complete a work in 16 days. So remember, 14 people can finish a work in 16 days. Okay, fine. Yes. Now let's start from this piece of information itself. Okay, 14 people, a group of 14 people are working and they are able to finish a work in 16 days. So let me take this way. Let me take this way. One man in one day, can do 1 unit of work. One man can perform 1 unit of work in one day. Okay, this is my assumption. That's my efficiency assumption. Okay, fine. Yes. Then that means students, can you please tell me the total work will be how many units? It's very easy to calculate. Now see here, if 14 people can finish the entire work in 16 days, then what does it mean? Then that means if one man can do 1 day, 1 unit, then it means the same one man can do how many units in 16 days? In 16 days, he can do 16 units. Then 14 men can do how many units in 16 days? It will be just 16 into 14. And this will be the total work. Is it or not? Yes or no? This will be our total work. Okay, I think I got the answer. I'm able to see the answers. Good. Yes. So one man can do, 14 men can do how many totally how many units? 16 into 14. Can you please tell me what is 16 times of 14? 16 14s are what? Come on, please. Any answers? So what will be 16 into 14? Any quick answers, please? Hello, students? Because that will become the total work. It will be equal to 16 into 14. It will be, yeah, I think 224, right? Yes, so 224 units. So this will be the total work as per our assumption. Okay, all right, this is done. Now continue the question. Now 8 persons started the work. 12 days after they started the work, 8 more persons joined. This is our question condition. Okay, this is how the question flow goes. So what happens? How many people are beginning the work? 8 people are starting the work. Okay, 8 people are starting the work and they work for how many days? They work for 12 days. So 8 people, 12 days they are working. Students, shall we calculate if 8 people are working for the first 12 days, they will be able to complete how many units? Shall we calculate that? We all know one person can do 1 unit in 1 day. That means 8 people in 12 days can complete how many units? Very simple. For one person, 12 units. 8 person, 8 12s are 96 units. So 96 units will be getting over in this first 12 days. Okay, fine. Yes. Now after this 12 days, what happens? 8 more people are joining them. This is our question given. Okay. Now tell me, students, out of 224 units, 96 units are over. That means remaining how many units are there? Remaining how many units are there? 224 minus 96. Yes or no? This will be how much, students? This will be 224 minus 96 will be how much? It will be, yeah, it will be. Yeah, what will be that? 224 minus 96. Yeah, 96 units are already over. That's why, yeah, that will be 128 units. So 128 units are more pending. Now what happens? After 12 days, 8 more people joined. That means, students, tell me, hereafter how many people are going to work? Already there are 8 people. Now 8 more people are going to join, which means now there are 16 people. Now the 16 people are going to work this 128 units. And now tell me, this will take how many days? That's our question. Okay, that's our question. How many days will they take to complete the remaining work? We know the remaining work is 128 units, and this is done by 16 people, a team of 16 people. They will take how many days to complete the work? That is our question. Okay, fine. Yes. Yes or no? Yes. Yeah. So how many days, students? So how to complete it? Again, you have the same relation. One man can do 1 unit in 1 day. Then 16 people can do this 128 units in how many days? See here, 16 people can do in 1 day, they can do 16 units. So how many days they will take to complete this 128 units? Just divide 128 by 16. So this will give you the answer. I think the answer will be, if you divide, you get the answer as 8 days. So 8 days. So the remaining work will be completed in the next 8 days. That's your answer. Finished. Is that giving sense, students? Yes or no? Understand? So this is one approach with which you can do the problem. Of course, as I told, there are many approaches. There is a kind of inverse approach and all is also there. Okay, but it needs few other basics to be given. Okay, only then you can understand the essence of those tricks what we use there. So that is the reason I'm just going for a conventional method to give you the answer. Okay, well, fine. Yes. So I would like to give you some more interesting questions for you. Okay, there are many interesting questions, but due to time constraint, we are unable to do all the problems. So next, there's a very interesting question. There's a very interesting question here for you. So this is from again geometry and mensuration. Okay, so we can never skip this geometry mensuration. Why? Because it is going to occupy a considerable part in your NATA exam. That's why. Okay, so I think we can solve this geometry mensuration question. Students, this shall we go for the next question? If you permit, we can go for the next question. Yes, can I? Can I? Yeah, I'll come down. Yes. Students, I want you to try this question. A very technical question. But of course, it's a very, very easy question. Concept-wise, it's a very easy question. Maybe the way you set up, you see the problem, that will make you to get the answer in a very easy and efficient way. Can you please try this question, students? Come on, please try this question. Maybe if you want, I will explain the question. I'll explain the question. A circle of maximum possible size is cut from a square sheet. Subsequently, a square of maximum size is cut from the resultant circle. Then what will be the area of the final square? So this is our question. Okay, so maybe if you want, yeah, maybe if you want, I will draw a picture of what is given there in the question. So initially you take a square, you take a square sheet. Okay, maybe the way I'm drawing is not looking as though it is a square, so apologies from my side. Yeah, now it is looking somewhat better. Yeah, okay, so you take a square sheet, you are going to cut a maximum possible circle from this. Okay, so maximum possible circle will be something like this. Okay, maximum circle will look like this. Okay, yes, I deeply apologize for the way what I'm drawing, but it is a circle. Okay, I want you to kindly understand it. So you cut a circle, and once again what you do is, from this circle you again cut a maximum possible square inside that circle. Okay, yes, yeah, you cut a maximum possible, yes, square from this one. This is how it looks. Then what's the question? What will be the area of the final square? So the innermost square, you see, no, what is its area? That's our question. Okay, So maybe can you give the answer, students? Come on, come on, come on, quick. Can you give the answer? And I've got one more question also. Maybe if we have a quickly get a revise time, we can do it quickly. Yeah, first we'll finish off this question. So any answers, students? Any answers for this? So kindly work the question and then get the answer. Yeah, I can see the answers in the chat box. Good, nice to see that. So a square inside a circle, which is again inside a square. Yes, any answers? And I advise you, you should be very, very careful. You can take some good numbers and then work the problem, students. That will be a better approach. That will really be a good approach for you to get the answer. Okay, fine. Yes, come on. We'll finish off this quickly. Now see here, students. Let me do something like this. Okay, fine. I will take the outermost square, the side to be 10. I'll take this as 10. Understand? Okay, fine. Yes. That means it's very clear that the area of the outermost square will be what, students? Area of the outermost square will be 10 tens are 100. Okay, so the bigger square area will be 100. No doubt in that, because we all know area of the square is side into side. So 10 tens are 100. Finished. Okay. Now once the side of the outer square is 10, what can be observed about the circle, students? What you can tell about the circle? Please, can you please tell me what you can tell about the circle? What you can tell about the circle's measure? Anyone can please tell me that? If the side of the outer square is 10, then what about the, yeah, very good, very good. I got a good thing about the circle thing. Yeah, very good. From Kiran, I'm able to see the response. Very good, very good, very good. Exactly. So all you can tell is, you can tell the diameter of the circle is also 10. Is it or not? Because side of the square is same as the diameter of the circle. Okay, fine. Yes. So that means the diameter of the circle is 10. Okay, I'll write the circle's measures here. Circle diameter is 10, which means radius is 5. That means what about the area of the circle? Area of the circle will be, that will be pi into 5 square, which means 25 pi. Okay, students, as of now, let us not take the values to simplify. Let's have it as it is, 25 pi. Let's have it as it is. Okay, so we got the area of the circle also. This is 25 pi. Now come to the innermost square. Now what can be told about the innermost square? I will give you a hint. Just try to draw a diagonal for the square. You form a diagonal of the square. Now what about the diagonal of this square? Diagonal of that square is what of that circle? Can you please tell me? It will be what? Diagonal of the square. Diagonal of the square. Please listen carefully. Good, good, good. Very good, very good. Yeah. Kiran, Laila. Good, great. Nice to see that. Really nice. Very good. So that means diagonal of this square is same as the diameter of that circle. So which means I can very well confirm that diagonal of the square, I mean the small square. Okay, I'll write it clearly. So diagonal of the small square will be same 10. Okay, yes. That means what about the side of the small square, students? Side will be what? Or otherwise, I will take the side of the small square as, I'll take it as A. This is A, this is A, this is A. Okay. So this diagonal is 10. Just now we confirmed, right? This is 10. That means this A value will be what? What will be A? I can build a relation here, right? Since this is a square, the angles will be right angles. A square plus A square is what is 10 square. That means 2A square is 100. So A square will be 100 by 2. Correct? Or otherwise I can rewrite A is 10 by root 2. I will have it like this, 10 by root 2. Now tell about the area of the small square. What will be the area of the smaller square, students? I will slightly come down because there's no space for me. That's why. Area of the small square will be what? Now we got the area, I mean side is 10 by root 2, 10 by root 2. So area will be 10 by root 2 into 10 by root 2. Because for small square, the side is 10 by root 2. Its area will be 10 by root 2 the whole square. That's what I've written here. Can you please tell what will be this 10 by root 2 into 10 by root 2? This is nothing but 50. Is it or not? Yes or no? Check it carefully because 10 tens are 100. Denominator root 2 into root 2 will be 2. So 100 by 2, you will result with 50, which means the smaller square's area is 50. I think this is enough for you to confirm which among them is the correct answer. Which among the options is the right answer. Now look at all the area quantities. Look at all the quantities. Small square area is 50. Now look at the options. It is matching to which answer? It is matching with which answer? Please check it carefully. 75% of the original square. Is it? 75% of my original square has to be 75. So it's not the right answer. 50% of the original square. Yeah, original square is 100. Bigger square is 100. Smaller square is 50. So 50%, exactly 50%. Option B is right answer. Okay. But anyways, we'll check the other options. 75% of the size of the circle. Is it true? 75% of 25 pi. Will it be valid? 75% of 25 pi will be not exactly this 50. Correct? Okay. Next, 25% of the side of the original square. That will be 2 less. Again, that is not our answer. So option B is the right answer for the question. Okay. Yes. Is that okay, students? Is that okay? Yeah. Students, I want you to try one last question, a very good question based on circles. So I thought I can give you this question. So one last question for you, please. I will give you this question. So I think you are able to settle down with this question. Is this question okay? The last question is okay to your students. So it is just a proper way you look at the diagram. You see the diagram, the way it is present. Okay, fine, yes. So that will make you to decide and get the answer. Okay, fine, yes. Anyways, we'll move on to one more question, one last question for you. So I thought like these kind of questions may really help you to get a good logical thinking. That's why. Yeah, okay. I got one doubt from Kiran. Yes, Kiran, I'll get back to that. Yes, what is your doubt, Kiran? Yeah, I'll definitely give that. So I'm coming back to the same question. Yeah. You have the doubts in this last step, right? In this last step, right? So yeah, this one. You mean like this one? Yeah. Sure. I'll explain that step. Okay. So I'll explain it for you. So now you see here, I'm just using Pythagoras theorem here. This is A, this is A. So A square plus A square is equal to 100, 10 square, which is 100. So that's why I gave you 2A square is 100. Okay. So once 2A square is 100, A square will be 100 by 2, right? 100 by 2. So A square is 100 by 2. I'm not finding what is 100 by 2. I know it is 50. I'm not writing that 100 by 2 as 50. Instead, what I'm doing is here itself, I'm taking the square root. If A square is 100 by 2, then A will be what? I have to take the square root on right hand side. So root 100 by root 2. Root 100 is what I wrote as 10. Root 2 is simply as it is root 2. So that's how I got A is 10 by root 2. You understand? That's what I am putting inside this box. Now understand that? Now able to understand that? Yes. So A is 10 by root 2. So that means that A is nothing but the side of the small square. Okay. And from there we get the area. Yeah, of course. Yes. Yeah, that we can do that. Yes. So as Samad Sheikh is asking another doubt, Of course, we can use that relation also. I mean, to find the area of the square only, right? So that's what you refer, right? Definitely we can do that. Yes. So that's again a general formula we use to find out the area of the square. So this will be like what? This will be like um like area of the square is a square. This is in terms of side. You can rewrite the area as half of d square, diagonal square. This way also we can write it. Okay. So once you know that, you can easily get the area. Half into 10 square, which will be 50. Yeah, of course we can do that. Okay. Yes. 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 Yeah. Yes. 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 Last one question for you students. Come on, please. Yes, great. I think I got one correct answer. I got one answer from Sarat Chandra. Nice, 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 brilliant. Pranesh, Chitragupta. Good, very good. Yes. Yeah, yes, students. So coming back to this question, there's a circle with center and radius 25 centimeter. Okay. I'll quickly draw one circle for you. So there is a circle. Okay. Yes. Given the center is O. And they gave the radius is 25 centimeter. Radius means from this center point anywhere on the circumference, the distance is 25. And given AB is a chord of length 14 centimeter. Okay, fine. Yes. So that means there is a chord AB. Okay, let me draw the chord like this. I will draw the chord something like this. Okay, I'll draw it a bit carefully. Yeah, I will draw the chord like this. So now see here, this is A, this is B. So chord AB, whose length is 14 centimeter. And the radius is 25 centimeter. Let me do something. I will join OA, this is 25, and OB, this is also 25. Yes or no? You agree with that? Because OA is also radius, OB is also radius. Okay, fine, yes. Now the question is very simple. Find the area of the triangle AOB. You need to find the area of the triangle AOB. Got it? That is our question. Okay, yes. Now remember, AB is what actually here? AB is a chord, right? Chord means a straight line or a line segment that will connect 2 points inside the circle. Okay, fine. 2 points on the circumference, that line will be present inside the circle. Such a line is what you call it to be a chord. Okay. Now let's do some small kind of adjustment here. I will drop one straight line from the center O till here. And I will name the point as this point as some C, OC. Now, once I drop like this, I will drop it as a perpendicular line. And there's a property that when you drop a perpendicular line to the chord, this chord will be bisected. What do you mean by bisected, students? Bisected means this chord length will be equally divided into 2 pieces. So we know, just now we got to know AB is 14, right? It's there in the question itself. So that means this point C will divide this AB as 7 and 7. Got it? Understand? Yes, fine. Now you can very well see you have got a right angle triangle formed here. OAC. OAC is a right angle triangle, right? OAC. OAC is a right angle triangle. And of course, we can use Pythagoras theorem there, right? So OC square plus AC square is equal to OA square, because OA is like our hypotenuse. That's why. Correct? Yes. So continuing that, we'll be getting what? We'll be getting it as, just put the values here. So once I put the values, I will be getting OC square plus AC is 7 square and OA is 25 square. Now, can you try to solve this value and get the value of OC, students? OC is what? Can you please get the value? OC. Yeah, meanwhile, I'm able to see many of you giving the answers. Good to see that. Yeah, come on. First of all, OC is what, students? Use the Pythagoras theorem and then get the answer. So I think you can get the value of OC as 25 square minus 7 square, then you take a square root. So what do you get there? What will you get there? You'll get it as how much? Hello? Any answers? So 25 square will be actually 625. 7 square is 49. So if you minus, you will be getting what? I think you'll be getting 576, right? And so 576 will be what? Yeah, 576. And 576 is basically which number square? So OC square is what is 576, right? I want you to tell what is OC. That's what I'm asking. So OC will be. Students, are you okay how this 576 came? If you want, I'll explain that. Okay, 25 square is 625. 7 square is 49. So you have to do minus 625 minus 49. Why? Because this plus 7 square goes here to the other side. It becomes minus 7 square. So you do minus. So that's how you get this 576. So OC is what, students? OC is, yeah, exactly. It will be 24. Yeah, OC is 24 centimeter. Got it? Now coming back to the question, what is the area of the triangle AOB? So area of the triangle is half into base into height. Now look at our triangle, students. Our triangle is present there in such a way that it is like sleeping there. Yes or no? It is present in a like a kind of horizontal way. It is present. So half into our base is like AB and our height is like OC. Now this is enough for you to tell the answer. Half into, we know both these quantities. AB is 14 and OC is just now we got 24. So that's it. I think now you can get the answer. So what will be the answer, students? Half into 24 into 14. The answer will be what? So what will be the answer? So maybe you can cut this 14 and 2 7 times. So you get 24 into 7. That gives you what, students? 140 and 28, 168 centimeter square, because we are finding the area. So area will be in square units. Okay. So 168 centimeter square will be the area of your triangle. Got it? Able to understand this? So such interesting kind of questions also you will be getting in the exams. Okay, fine. Yes. So I don't say that these will be very hard questions, but still, the way you are going to take it, approach, that matters. Okay. So the way you are going to present it in a diagram itself will enhance you to see the problem in a very good way. Okay. Yes. So then from there onwards, you try to use the basic logics like Pythagoras theorem or whatever, then you can get the answer. You can easily get the answer. Yes. All right, students. All right. So yeah, yes, students. So yeah, I think we'll wind the session up, wind up the session here. And yes, students, as usual, there is a curiosity test given. There's an announcement already given by our sir, right? So there's a curiosity test conducted, and today 9 p.m. Okay, so the test will be there. So I do wish all of you to participate for that test also. So have a better practice. So this will enhance your practice for your exam. And also there's an upcoming NATA exam for you in this coming week. So I want you to perform it in a better way. Okay, fine. Yes, students. So I wish you all the very best for you, for all of you to perform better, perform well in that exam. And please do it with a good practice. Okay, fine. Yes. So once again, wishing all of you all the very best. So do well for the exam. Okay. Yes, students. Yes, students. Yes. So yeah, thank you all of you. Thank you all of you, students. All the very best, and thank you all of you. So see you maybe in some other session. We'll catch up there. Okay. Yes. Yes, students. Thank you all of you, students. Bye. Take care. Thank you.